Okay, we have a situation where we know that Frenchmen Frenchmen eat 100 pounds of cheese per year. Okay, and we think that they eat less. Okay, average Frenchman eats 100 pounds, mu equals 100 pounds of cheese per year. We think Americans eat less, but we want to prove that they eat less. We want to take a sample of Americans and compare it to the known mean for Frenchmen, which is 100, and see if we can say with 95% certainty that Americans eat less cheese than Frenchmen do. Okay, so now we have to have a starting point here in order for us to, have an idea of whether or not we can prove this and how big a sample we need to prove it. Now, remember, when we estimate how much, what we're going to do is we're going to go out and we're going to ask Americans, how much cheese do you eat? And somebody's going to say 80 pounds a year. Somebody else is going to say 92 pounds a year. Somebody else is going to say 101 pounds a year. And we're going to add those up, find an average. And then we're going to calculate a confidence interval. Okay, so we have to figure for ourselves that what's going to affect that confidence interval? What's going to determine how wide that confidence interval is? Well, what's going to determine how wide that confidence interval is going to be number one, how variable these numbers are, the standard error, what the standard deviation or standard error is for these values. That's one thing that's going to do that. Okay, the other thing that's going to do it is make this determine how wide that confidence interval is and how big a sample we need is the sample size. The bigger the sample size is, remember, we're going to take that, the way we calculate standard error is we take sigma and divide it by the square root of n. The bigger the sample size is, the smaller the standard deviation is, the smaller the number we add and subtract to the mean is, so the narrower that range is, right? So the bigger the sample size is, the more accurately we can calculate the mean, our estimate, our x bar, or our estimate of the mu, the mean for how much cheese Americans eat. Okay, now I'm going to say Frenchmen, that standard deviation for the amount of cheese the Frenchmen eat is 20 pounds. Eat 100 pounds per year of cheese per person with a standard deviation of a known standard deviation of 20 pounds. Okay, so now I need to know, I want to estimate what my sample size has to be in order for me to prove that Americans eat less cheese than Frenchmen do. Okay, so I'm going to start with the assumption that, I want to be able a significant, I don't want to prove that, well, Americans eat 99 pounds, because that's really, that means like there's basically no difference. Even though I might be able to prove they eat 99 pounds instead of 100, there's really no difference between eating 99 and 100 pounds. I mean, clinically or in terms of like, grossness, there's really no difference between eating a third of a pound a day and 0.32 pounds per day or something like that, whatever this works out to. Okay, so now, so I'm going to pick out a number that's, decently different than 100 pounds. Let's say I want to be able to prove this, assuming that Americans eat 90 pounds per year. What sample size do I need in order to prove that with 95% certainty? In other words, alpha is equal to 0.05. Okay, what sample size do I need there? Well, we're lucky in that this really involves looking at what I think the distributions for Americans would be if this were 90, and seeing how much it overlaps with the standard deviation, given the same standard deviation in populations, how much it overlaps for Frenchmen who are 100, and how close they, if we use a sample size of n, what 95% confidence interval is here, what it is there, and how much they overlap, and what area this is, and what area this is. There's a relatively complicated way of doing this by actually looking at the distributions of the two populations, or samples from the two populations, and seeing how much they overlap, and how much the areas of their distributions, the sample distributions, overlap. However, we have a shortcut that we can use. We have a formula that says n is equal to the z-score for alpha over 2, right? That's our level of confidence, 95% confidence, 5% chance of error. Alpha over 2 would be a 2.5% in the tail, times my standard deviation, right? Times my standard deviation divided by my margin of error. You might see that it's just a big E. I'm going to put ME as for same margin of error. And I'm going to take that number and whatever it comes out to be and square it. That's my That's the sample size that I need in order to prove that these are different, assuming that I think Americans eat 90 pounds compared to the 100 that Frenchmen eat. Okay, so if it is 90 pounds, and assuming that the standard deviation for both populations is the spread of the amount within each group is the same, standard deviation is 20 pounds in each one of them, what sample size would I need if this were really true? Okay, so now let's take a look at this. If I say the sample size is going to be equal to z over, it's going to be 1.96, right, times sigma, which is 20, divided by my margin of error. Well, let me take a look at this. Here's a number line here. Here's Frenchman right here at 100 pounds, right? Here's Americans here at 90 pounds, right? So I need my confidence. Here's what I think it is. So I need a confidence interval for Americans that allows me to have a distance of at least 10 between the value I think it is for Americans and the value for Frenchmen. But at the same time, confidence interval goes both ways. So it's going to go 10 below as well. So my margin of error here, if I'm saying my mean is 90, what is my margin of error here? My margin of error here is 10. That's what I want. My confidence interval is going to be 80 to 99, is 80 to 99.999, right? Just below 100, right? But my margin of error is only the top half of that. That's the difference between my mean and that level. Say that's the amount that I add and subtract to my X bar to calculate my confidence interval. My margin of error is going to be 10. So I'm going to put a 10 down here. And I'm going to work this out. I'm going to square this whole thing. Well, for starters, I can just say 10 into 20 is 10. 1.96 times 10 is 19.6. 19.6 squared is, let's say 20 squared is 400. And if I am correct, it appears that I would need a sample size of 400 people given this standard deviation and this then the margin of error that I want in order to have a shot at proving this, having a narrow enough confidence interval to say that 100 is outside of that confidence interval. Okay, okay, do you guys feel comfortable with that? Does that make sense to you? I need some feedback because I know the sample size stuff can be a little confusing.